This is PreCalculus 12, Chapter 5.1. We're going to be looking at graphing exponentials. And we're going to be doing it from tables to start off with. Exponential functions look like powers. However, there's a major difference. The variable is in the exponent rather than the base, and the base must be a positive constant. So it looks like this. Y equals a to the power of x. And the domain for exponential functions is all reals. So let's take a look at x squared versus 2 to the power of x. Here we have our table of x's, and here we have x squared and 2 to the power of x. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. However, if we look at 2 to the x, 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, and 2 to the 5 is 32. And if we continue on, we see that 2 to the x is growing much faster than x squared. By the time we get to 12, 12 squared is only 144, but 2 to the power of 12 is already over 4,000. Okay, let's try this with a different base. Let's try this with x to the power of 4 and 4 to the power of x. X to the power of 4, 4 to the power of x. X to the power of 4, 4 to the power of x. Again, the numbers, when they're small, they're very close. Even when we get to 5, 4 to the x starts growing faster. And if we look at 13 to the power of 4, we get over 28,000. But 4 to the power of 13, this is 67 million. So again, grows much faster. Let's look at something a little bit different. So x to the power of half, this is square root x. And we have 1/2 to the power of x. Okay, we see square root. Square root 1 is 1. Square root 4 is 2. Square root 9 is 3. Let's look at 1/2 to the power of x. 1/2 to the power of 0 is 1. 1/2 to the power of 1 is 0.5. 1/2 to the power of 2 is 0.25. We see that square root x is increasing. 1/2 to the power of x is actually decreasing. And this is increasing. And if we examine a little further, this is not converging. And the other word for this is diverging. This is converging, and it's converging to 0. We see the numbers are getting closer and closer to 0, and it won't reach 0. Okay, let's look at 2 to the power of negative x and 1/2 to the power of x. So this is 2 to the negative x, 1/2 to the power of x. So 2 to the power of 0 is 1. 1/2 to the power of 0 is 1. 2 to the power of negative 1 is 0.5. 1/2 to the power of 1 is 0.5. And if we examine these two, all the numbers are the same. So if we look at doing some algebra, we take this. This is 2 to the power of negative 1 times x. And this can be written as 1/2 to the power of x. So they're the same. And we note horizontal asymptote, y equals 0. And for one end, that means going to infinity. We see that it's going to 0. For other end, no horizontal asymptote. It just goes to infinity. Okay, so if you're able to understand this and work on your own, you can stop here and do the assigned questions. If you need more help, continue watching and get some more hints. So, for untransformed exponential functions, i.e., no transformations, they're always increasing or decreasing. And this is not true for polynomials. So you're looking at a different kind of function. Untransformed functions have a horizontal asymptote. And again, not true for polynomials. If the base is less than 1, this is a decreasing function. And if the base is greater than 1, this is an increasing function. And we'll note this is reversed if y equals a to the power of negative x. Recall that this is a transform, and it's a horizontal reflection. Now, regardless of the base, the horizontal asymptote is y equals 0. And the range is y is greater than 0 for untransformed functions. Recall we can have y equals negative a to the power of x. Recall that this is a reflection on the x-axis. So in this case, it would be y is less than 0. Okay, and you can go to the videos that shows you how to set up tables if that's what you would like to learn. But that completes this lesson.